I welcome you all to the class. In the previous class, we were talking about the kinetics of rigid body. And in the previous class, we talked about the two equations that are used for defining the motion of a rigid body. In kinetics, from the previous class, at least you may be now visualizing at least that whenever we are, whatever we are doing about whatever we are asked to do about the problem of a rigid body, the way we have to solve or the parameters we have to calculate, all the parameters, calculation of parameters in one way or the other requires the free body diagram, that is requires introduction or understanding of the forces acting on the rigid body. That is what the kinetics does. In the kinetics of rigid body, we talk about the motion of a rigid body by taking into consideration the forces that do act on the rigid body. In the previous class, we defined the two equations of the kinetics of a rigid body. We defined the two equations by which we study the kinetics of the rigid body, or we also call them the kinetic equations of the rigid body. The first and foremost equation we said was that the summation of all the forces acting on the rigid body is equal to the product of its mass and the acceleration of center of mass or center of gravity of the rigid body. This is the first equation we were talking about yesterday. And as far as the second equation is concerned, the second equation that we discussed yesterday was about the moments. We said that summation of all the moments of a rigid body about any point P, okay, is equal to the cross product. It's equal to the cross product of the radius vector drawn from point P, drawn from the point about which you are calculating the moments, to the center of gravity, cross mass times the acceleration of center of mass of a rigid body. Okay, these two equations we were discussing in the previous class. Now, if you look at both the two equations, as far as force is equal to product of mass into acceleration is concerned, and this equation of moments is concerned, the question is why two equations are required to define the motion of a rigid body. The reason for that is that whenever a rigid body is in motion, the motion of a rigid body can be summation of two motions, translation and rotation. Okay. For example, what you have in front of your screens is the motion of this motorcyclist. Okay. So a motorcyclist is riding a bike. He's riding a bicycle. He's riding a motorcycle. And look at the motion of the tires. If you look at the motion of the tires are undergoing the rotational motion. Okay. But if you look at the motion of this rider, at some instant of time, the rider is here. After some instant of time, the rider reaches here, then he reaches here. So the motion of the rider is a translational motion, but there are some parts of this system whose motion is not or translational, but also rotational. Okay. So as far as we are talking about the motion, which is the general plane motion. Okay. And I have told you through an example of that whiteboard, the duster, use it for rubbing the whiteboard. The motion of the duster on a plane, on the plane of the board, is simply the motion which is combination of the translational motion and the rotational motion. That's why we are using two equations. That's why the application or the utilization of these two equations is very important, because this equation will tell us about the translational motion of the rigid body, and this will define the rotational motion of the rigid body. But yes, if the rigid body does not have the rotational motion, but it's only translational motion, we will see in the problems, then this term will become equal to zero essentially. Okay. And the only equation that will define the motion of the rigid body will be equal to F is equal to mass into acceleration. Okay. Now let's take up a problem right now. The question says that the motorcycle shown in figure this has a mass of 125 kg. We're having a motorcycle and the mass of this motorcycle is 125 kg and a center of mass at G1. Okay, if you look at this motorcycle, the mass of this motorcycle is 125 kg and the center of gravity of this motorcycle is at C1. Okay, exactly over the engine. Okay, engine being the heaviest part of the the motorcycle. That's why the center of mass will be somewhere around, or the center of gravity will be somewhere around that engine. Okay, so the question says that the center of gravity of the motorcycle is at G1. Okay, while the rider has a mass of 75 kg, the rider happens to be a fat man and its mass is around 75 kg, and this 75 kg of mass and a center of mass at G2. And if you look at the motorcyclist, okay, the motorcyclist center of gravity is at G2. Okay, so we are having two centers of gravity. One center of gravity belongs to the motorcycle, okay, that is G1, and another center of gravity belongs to the rider, and it is G2. Now the question says, determine the minimum coefficient of static friction between the wheels and the pavement in order for the rider to do a wheelie. This is very important. Okay, uh, now what the rider wants to perform the wheelie. Okay, when you talk about the wheelie, what do we mean by wheelie? Wheelie means that the rider wants to lift his front tire in air. Okay, the rider wants to lift his front tire in air and wants to ride this motorcycle on only the rear wheel. Okay, so this is the rear wheel, this is the rear wheel, and this is the front wheel. What the rider wants, the rider attempts to lift the front wheel in air and ride the motorcycle only on the rear wheel. That is the picture that is given here. If you look here, this is called wheeling. Okay, this is called wheelie. He wants to lift the front tire and wants to perform the motion on the rear tire. Okay, lift the front wheel off the road as shown in the photo. Okay, that's here. What is the acceleration? What acceleration is needed today to do this? How much will be the acceleration? How much acceleration the motorcycle should have to perform the wheelie? Now it says neglect the mass of the wheels and assume the front wheel is free to roll. That is, you assume that the front wheel is free to roll and the mass of these wheels is negligible. Okay, so what do we want? What do we want? We want that the front wheel should go up. The motorcycle has to perform the wheel. Now, before we perform, now we first of all, we have to find the coefficient of friction between the wheels and the pavement. That's the road. Number one. Number two, we have to find the acceleration. Okay, so we have to find the two things. Now, how do we do the kinetic problems? Okay, you have to find the acceleration. You have to find the acceleration problem A. Now, if we had we, you know, if we had if we perform the analysis, the kinematic analysis, then we don't need a free body diagram. But this analysis needs to be performed through kinetics. Therefore, a free body diagram or the introduction to the forces becomes very, very important. So first of all, we should see what type of forces are acting on the rigid body. That is, first of all, let's draw the free body diagram as is given here. I will not waste time in drawing the free body diagram. I will use the free body diagram as drawn by the author. Now, first of all, as far as the rider is concerned, the mass of the rider is 75 kg. Okay, so it means 75 into 9.81 Newton, 75 into 9.81 Newton force will be acting through the center of gravity of this, motorcyclist. Okay, because the mass of the motorcyclist is how much? It is 75 kg. So when we calculate 75 into 9.81, it comes out equal to, so 75 multiplied by 9.81, it comes out equal to 735.75. That is here. Okay, so this much force will be acting downwards. Okay, through the center of gravity of this motorcyclist. Now look at the motorcycle. The mass of the motorcycle is how much? 125 kg. Therefore, the gravitational force of this motorcycle will be 125 kg multiplied by 9.81 meter per second square. That comes out equal to 125 multiplied by 9.81. That becomes equal to 1226.25. That becomes equal to 1226.25. Okay, and that is given here. Okay, let's here. So this much force, by this much force, this force will, this is the gravitational weight of the motorcycle, and it will be acting towards the center of the earth through the center of gravity of this motorcycle. Okay, so we have done it. Number three is very, very important. Look at the front wheel. As far as when the motorcyclist motorcyclist performs the wheelie, okay, at that time the front wheel will be in air. When the front wheel goes in the air, the contact of the front wheel with the ground is lost. There is no contact between the front wheel and the ground. When there is no contact between the front wheel and the ground, therefore there will be no reaction force exerted by the ground on the wheel. Okay, there will be no reaction force. Okay, because this wheel is in air as here. Number Three is so there will be no force acting on the wheel because this wheel is in air. Now look at the rear wheel. Since the rear wheel is on the ground, okay, so as far as the rear wheel is concerned, our rear wheel of the motorcycle is in ground. The rear wheel happens to be in ground. When the rear wheel happens to be in ground and this motorcycle is moving in forward direction, that is only possible when this wheel will be undergoing the anti-clockwise rotations. The wheel must have the anti-clockwise rotation so that the motorcycle moves forward. Okay. Now, as far as the ground is concerned, so this wheel is exerting some force on the ground in the downward direction, as a result of which the ground will be exerting equal and opposite force in equal and opposite reaction. Okay, so that reaction we call as NB. What is this NB? You should always remember, whenever there is a contact between two bodies, one body exerts a contact force on the another body. Okay, so the force that will be acting on the wheel will be NB. NB is the reaction force, and this reaction force will be in a direction opposite to the force exerted by the wheel on the ground. Okay, since we are drawing the free body diagram of this motorcycle, so we have to calculate all the forces that are acting on the motorcycle, and NB will be acting in the this. As far as this NB is concerned, this NB will be acting in the upward direction. This NB is what you call as the reaction force. Now, apart from reaction force, since it says that there is a frictional force between, there will be a frictional force between the wheels and the road. Now, what is the direction of the frictional force? Always remember, this is very, very important, that as far as the frictional force direction is concerned, look at the motion of this wheel. As far as the wheel is rotating, the sense of rotation of the wheel is anti-clockwise. Okay, the sense of rotation of the wheel is anti-clockwise. The force of friction will oppose the motion of this wheel. That is, the force of friction will be created in such a way that it will produce torque on the wheel in such a way such that it creates the reaction moment that tries to rotate the wheel in the anti-clockwise direction. Okay, I mean to say, if you look at the wheel, the wheel is rotating in clockwise direction. Clockwise. For the motorcycle to go forward, the wheel will be rotating in clockwise direction. Okay, but the frictional force created at the wheel, created at the interface between the wheel and the road will be such that it creates the rotation in anti-clockwise direction. That is, the force of friction has to be in this direction, because this is the center of the wheel. Okay, from center of the wheel draw a radius r. Okay, now reduce this r, move from r to f through the smallest angle. As you move from r to f through the smallest angle, because you know torque is equal to r cross f. Okay, and what will be the sense of the torque, whether this torque is clockwise and anti-clockwise, that direction will be given by the smallest angle, by the sense of the smallest angle as we move from r to f. Okay, as we move from this r to f, the sense of rotation will be anti-clockwise. Okay, that is only possible, that's only possible when this torque will be acting, when this torque, sorry, when the force of friction will be acting in this direction. Okay, that is, when the force of friction is acting in the same direction as the direction of motion of this motorcycle, this frictional force creates the torque in a direction opposite to the motion of this wheel. Wheel is trying to rotate in clockwise direction. The frictional force will be in such a way that it creates the anti-clockwise torque. Okay, so it means, as far as the forces now on the motorcycle are concerned, the forces on the motorcycle are, we are having this force, we're having this force, we're having force of friction, and we're having the reaction force. Okay, now we know, let's write down our equations of motion. We know summation of all the forces. Since this motorcycle, let's call this to be our x-axis, let's suppose this is our x-axis, and let's treat this to be our y-axis. Summation of all the forces acting on the motorcycle along x-axis is the product of mass of the motorcycle multiplied by the acceleration along x-axis. Okay, okay, so which forces are acting along x-axis? Now the forces acting along x-axis are, let's write the force along x-axis first. The forces that are, since this is center of gravity, this motorcycle, entire motorcycle is moving along x-axis, let's suppose with an acceleration, with an acceleration a along x-axis. Okay, since motorcycle and the motorcyclist is a single system, whatever is the acceleration of the motorcycle, the same will be the acceleration of the rider. Okay, so it means, as far as the rider is concerned, the rider is also moving forward with an acceleration of a meter per second square. Okay, and as far as the motorcycle is concerned, the motorcycle is also moving forward with an acceleration of a meter per second square. And we know by Newton's law, force is the product of mass and acceleration. Since the motorcyclist is having some mass, it is having some acceleration, therefore there will be some force acting on the motorcyclist in the direction of its acceleration. In the same way, since this motorcycle is having some mass, it's having acceleration a, therefore it will also have the force acting on it. Let me call this as force 1, and it will also have the force acting on it along x-axis. Let me call that as F2. Therefore, all the forces acting along x-axis are F1 force. F1 is the force acting along x-axis, plus F2 is the force acting along x-axis. Okay, and there is also one more force acting along x-axis, that is FB. Okay, I will write this as FB. Or before I write this FB, let me first use the first equation of motion as is written here. Let me first of all use the first equation of motion. Okay, the first equation of motion is forces acting along x-axis. You are having one force acting in this direction, another force acting in this direction, which are actually I write this as um, f f the summation of all the force along x-axis. So I'm having this force. Okay, this force is FB, frictional force. I will write this as frictional force at point B, plus the force of force because of this mass force on the rider, that's equal to the mass of the rider, that is 75 kg, okay, multiplied by its acceleration, plus 125 kg is the mass of motorcycle multiplied by the acceleration. Okay, so if you look at all these forces, okay, FB is the frictional force. Okay, FB is the frictional force. And as far as the rest of the forces are concerned, 75 kg mass into acceleration will be the force acting on the rider. 125 kg mass multiplied by acceleration will be the force acting on the motorcycle. Okay, so we know from Newton's law, F is equal to the product of mass and acceleration. F is the product of mass and acceleration. Okay, force is the product of, F is the product of mass and acceleration. Therefore we can write the mass and acceleration is 75 plus 125. 75 plus 125 becomes 200. So 200 multiplied by A. We don't know the acceleration, we have to find this acceleration. This will be the force. Okay, in fact, if you, from this equation, FB is equal to the product of mass and acceleration. Okay, so the force FB we can write as FB becomes equal to the product of mass and acceleration. Let's call this as equation 1. Okay, now I have just told you that there are two equations for, since initially this motorcyclist had both the wheels on the ground, but after some time what happened, the motorcyclist performed the wheelie and lifted the front tire up. As the front tire is being lifted up, now with respect to the ground, this wheel has defined some angle. Okay, we call this as angle theta. So it means the wheelie is possible when some angular motion has been introduced because of some angular motion. As the wheel moves up, so it describes some angle with respect to the ground. So because of this angular motion, okay, because of this angular motion, we are actually getting, because of the angular motion, what we are getting, we are able to perform the wheelie. Okay, so that's why I told you earlier as well at the start of this class that summation of all the moments about any point P is equal to, as we performed, R radius vector drawn from point P to C cross M dA. Okay, this is the rotational motion. Why in this motion we are using the concept of rotation, torque, so on and so forth? Why this equation? Because this equation is used here. This equation tells us that this really is possible when some angular motion has been performed. Okay, so as the motorcyclist is moving forward, it is having some angle. Okay, it is having some angle with respect to the ground. So it's not only the linear motion, it's a combination of linear as well as the angular motion. That's why we have to use this equation as well. Okay, that's, if you look here, if you look, in fact, to save the time of the students, that's what has been done here. So F is equal to force at B is equal to this. Now summation of all the forces along y-axis, we are having NB acting along positive y-axis, that's plus NB. We are having a force of 735.75 acting along negative y direction, that is minus NY. And we are having a force of 1226.25 acting negative y-axis, that's why minus. Since there is no motion along y-axis, okay, as it performs the wheelie, it remains in this, it remains in this configuration for some time. Therefore, summation of all the forces along y-axis has to be equal to 0, because entire mass is moving along x-axis. There is no motion along y-axis. That is, acceleration is x along y-axis is 0. Therefore, summation of all the forces along y-axis has to be equal to 0. Okay, that's it. Now, this equation is fine. This equation is also fine. Now, let's use the equation summation of all the moments about point B. Let's take the moments about point B is equal to summation of all the moments about point B is equal to R cross R drawn from point P to the center of gravity cross with the force. Okay, force acting at that very point. Look at the point B. First of all, calculate the moment because of, at point B, calculate the moment because of 73.75. Calculate the moment because of 735.75 Newton. The moment will be force into force arm. The force is 735.75 Newton. It's acting downwards. Force arm is 0.4 meter and it's trying to rotate the entire system in the clockwise direction. That's why we are writing this negative, okay? Minus 735.75 Newton into 0.4, it's negative because it's trying to rotate it clockwise. In the same way, we have 1226.25 multiplied by the force arm from point B, that is 0.4 plus 0.4, which is equal to 0.8. And it's also trying to rotate. Once he performs the wheelie, these forces will try to rotate it clockwise. That's why it has been taken as negative. This is the moments at point B, okay? And these moments are because of the forces other than the forces which are created because of acceleration, okay? The reaction forces are not created because of acceleration. They are there because of the mass of the rider and mass of the motorcycle. But as far as they, so when you are taking the moments, when you are using MB, you have to take the moments because of the forces which are the forces created not by the acceleration. So we are having these reaction forces which create moment at point B. They have to be equal to, this has to be equal to the R cross F. Okay, the moment because of the forces which are because of acceleration. The forces which are because of acceleration is the force acting on G2 and is the force acting on G1. Okay, the force acting on G2 will be equal mass of the rider, that is 75, multiplied by its acceleration, that is A, and the mass on the motorcycle will be its mass, that is 125 kg, multiplied by its acceleration. Okay, now let's take the moment because of these forces. Look at 75 kg. So 75 into A, so 75 kg multiplied by acceleration AG, multiplied by the force arm from point B. If you look at the force form, that is 0.6 plus 0.3, that is 0.9. Again, when if you draw the radius vector from here to here, if you move from R to F, the sense of rotation will again be clockwise. That's why it is written here minus. Same is the case of moment because of 125A, that will be minus 125 AG into force arm, that is 0.6. Its motion is again, it's also trying to rotate it clockwise. That's why it is negative. Okay. Now, after doing this much, as you are writing the equation, so first we wrote this equation, linear translational equation. We wrote equation for forces along y-axis. Okay, then we wrote the equation for the moments. Now what we will do in this equation, from this equation we'll get the value of Ag. The value of Ag comes out equal to 8.95 meter per second square. Once we get the value of Ag, okay, once we get the value of Ag, so substitute the value of Ag. From this equation, at least we'll get the value of NB, reaction at point B. Okay, so NB can also be obtained. We'll obtain NB from this equation. AG we'll obtain from this equation. Now, as far as F is concerned, FB is concerned, substitute the value of AG in this equation. substitute the value of Ag in this equation. Once we substitute the value of Ag in this equation, we'll get the value of Fb as well. Okay, so we will obtain the value of Fb. Frictional force at the wheel has to be 1790 Newton. The reaction at B will be 1962 Newton, and the acceleration of the entire system will be 8.95 meter per second square. Now, as far as the force of friction is concerned, Fb is given as Fb is equal to coefficient of friction multiplied by the normal reaction at B. Okay, force of friction at B is 1790. That becomes equal to coefficient of friction multiplied by the normal reaction, that is equal to 1962. Therefore, from this we can also calculate the coefficient of friction at point B. Okay, from here we can also calculate the coefficient of friction, and that comes out equal 0.912. So for this motorcyclist to perform the wheelie, it has two motions, and I'm repeating it, it has two motions. One motion is it is translating forward along x-axis, and once he wants to perform the wheelie and tries to lift the front wheel up, he has to perform the rotational motion. So once the rotational motion is performed, once some angle is described with respect to ground, so that's why we are getting the equation of moments. Okay, had there not been anything like, had there not been, had it only been translation, then the question would have been different. Okay, so that's why while you are dealing with the kinetics of rigid body, you have to make use of both these equations.